that your mold remediation effort was unsatisfactory. He's got mold again. And you're brought back to the table to explain why. Now that's not a circumstance we look forward to. Has anybody here on the right side ever heard about that problem before? Good. What about the left side? Okay, great. So I live in Tampa, Florida. It's a hot, humid environment. And for the last 25 years, I've been involved with insurance litigation, principally on the insurance side. So after all those years as an expert witness, I get really picky about things. I look at things really carefully, no matter what side I represent. But I want to share with you some ideas that if you're in this situation, you can help diminish the possibility, I can't say eliminate, diminish the possibility of a lawsuit. But moreover, give you clues to identify before you leave the site that help defend your position that you did a great job. So there are a number of things. The first is the thermostat position of the fan, on or auto. I find generally people who migrate from Wisconsin and Michigan and so forth, when they come to Florida or to the south, they tend to put their thermostat in the on position all the time. It can have significant challenges because when the thermostat sets the fan in the on position in an air-conditioned environment, with the fan on, water from the evaporator coil is re-entrained through the ductwork back into the house. And you'd be surprised how it'll elevate the humidity into the 60–65% quite easily. And it'll mystify, if there's a mechanical engineer involved, often not them, but maybe a city worker who's involved with municipal properties, they will be mystified as to why that might happen. You turn it from on to auto, and within an hour and a half, it's dropped down into the 50s. So it's very effective. But the point is that that's something to look for when you do a remediation job, assuming that that hasn't been altered, is photograph the thermostat in the position they keep it in normally. And if you have to return, photograph it again. Temperature across the evaporator coil. It's a simple task, and I do it pretty often. Whenever there's a mold-related problem, is I take that small thermometer and push it through the air supply duct, being above the air handler, take the temperature on the air supply side, and then go down and take it on the air return side. What should that temperature difference be approximately? 15 degrees. 15 isn't bad, but 16 to 20 is normally a range. The whole point is that you want that moisture-laden air to pass over the cool evaporator coil at a temperature that encourages to meet the dew point, condense, accumulate, and run out the drain pan, right? And if there is a circumstance that prevents it to be too high or too low, it may not perform properly. So what are the circumstances that cause that delta T to be too high? Obstruction of the coil. So if you slow the air across the evaporator coil, it resides longer across the coil and is resultingly cooler. And the consequences are not only that it may be cooler, but the ductwork is cooler. As it goes to the attic, it may condense moisture that ends up as drips, linear drips, across the top of the ceiling. So it's to your advantage, if you're at a site, to inquire about that delta T. If you have a really competent mechanical engineering firm that's looking at that regularly for the homeowner or the business owner, they'll usually write that down. They'll write down the delta T. Now, if it's lower, then you're simply not going to reach frequently the dew point for the air passing over the evaporator coil. And that can happen too. And remarkably, some people actually slow down the air speed across the coil to elevate the humidity if the homeowner thinks it's too dry. But they'll actually modify the fan speed to have it go slower and hence be warmer and less of a delta T. So those are elements to think about in terms of trying to characterize what conditions changed during the course of before your work or afterward that may have contributed to mold growth. This is the common one, especially following successful mold remediation, is the homeowner. I'll just say this, usually it's older men from Illinois, Michigan, and Wisconsin who want want a bigger unit. It's I want it kind of cold. And they'll raise the tonnage at their insistence, a half a ton or 1 ton more. And it has devastating consequences because we'll short cycle. And they don't respect that. And I'm just looking on my phone, for 10 cents a square foot, you can have a manual J calculation done on your own, assuming you can provide a lot of the variables that's required in the equation. Now, the manual J calculation is the tonnage of air conditioning you use for your home. At 10 cents a square foot, that's a pretty cheap investment. But there are some circumstances where, there may be a larger system required. But there's more space. And they have some leaky windows, which is pretty unusual nowadays. But the point is that the decision to increase the size or the tonnage of your air conditioner is not always a good one unless it's substantiated by proper calculations. Now, this is the one that most people don't think about too much. It's the wiring of the thermostat and the humidistat. Now, when I grew up, we didn't have a humidistat. I grew up in Detroit. We just had a thermostat. It was simple. When you have a certain set point, when it reached the set point, either the heat would come on. We didn't have air conditioning, so it was mostly just heat. But when you have a thermostat, it's a very simple relationship. It's basically an on-off switch when the temperature reaches the set point temperature. Simple. Then you add a humidistat. Many people are confused about that. And you'll see these little signs on the side. Dad says place the humidistat at 35% when you leave for vacation, that kind of thing. So the wiring for a humidistat can have 2 options. It can be wired in series. By the way, I opened up a humidistat and looked at the directions. That's the first option provided to the electrician. It's also the simplest. So when it's wired in series, it means you have a set point temperature for the thermostat, one for the humidistat, and both have to be on or activated to turn on the heat or the air conditioning. So that's important because sometimes they don't necessarily agree. They have to be both on to activate the air conditioner. Or it can be done in parallel. And I'll just show you that. So in parallel, they're independent. So if the temperature rises and you want air conditioning, it reaches a set point, it activates the air conditioner. If the humidity rises and it reaches the humidity setting for the humidistat, it activates it. But they're independent. So depending upon whether or not the wiring for the thermostat and the humidistat are in series or parallel, you may have different outcomes in terms of the performance of the house. But if you want to check, if it's not running, just bump one or the other and see if it comes on. If it comes on, it's mostly probably in parallel, right? Because the other one will not have necessarily met the set point. So there is a way to tell in the field about the wiring. This is another mysterious thing about homeowners and laundry, as well as any other mechanical ventilation component in the house. And I find this in exotic, multi-million-dollar homes, and I find it in trailers, where the laundry is operated frequently because of a lot of kids and doing laundry. And if the air is discharged directly out of the home, it has to be made up. It's going to be made up through leaks in the doors, the windows, the attic vents, but it will be made up. And the point is that we don't realize that when you turn on your dryer, you're discharging, if with a full load, about 100 cubic feet per minute, perhaps more. Depending upon the capacity, it can go up to about 225 cubic feet per minute. Now, if you have a 60-minute cycle for the dryer, you're discharging now hot, humid air in the thousands of cubic feet per minute. If you do the calculation, you're actually getting rid of about 2/3 to 3/4 of all the air in your home with your dryer every hour. So I've been in circumstances where at an exotic home, and on the second floor they had 2 huge commercial washers and dryers on the second floor for the maids, and they were pushing out nearly 600 cubic feet per minute, wondering why there was mold growth around the windows. But they didn't want to accept the explanation. They wanted to sue the HVAC contractor, He must have done something wrong. It was a simple mechanical calculation on how much airflow was going out as a result of the dryer. Now, it can be complicated by other appliances too. I was in a mobile home the other day, and I had a microwave on high setting, discharged 400 cubic feet per minute. I didn't want to get too close to it, thinking it's sucked inside of it. But the point is that, and you combine the dryers, the microwaves, the vent above the oven, the bathroom fans, if you have them all on, you're getting rid of most of the air in the house within 30 to 60 minutes. And it's a contributing factor to mold growth because you're introducing moisture-laden air into the home through all kinds of cracks and crevices, which is, quite frankly, not easily accepted by the homeowner, that simply doing their laundry is somehow contributing to the mold in your home. With regard to flooring additions, is that sometimes when people remodel their home, they tend to raise the elevation of the floor where the air typically returns under the door. This is for non-ducted homes, which I think is maybe not the majority of homes in the United States, but it's a lot. And the point is that when you elevate with wood or carpet and essentially seal that space under the door, you're restricting air movement back to the air handler to remove the moisture-laden air and discharge it out of the house. So I find this to be particularly common in multi-family residences, where each homeowner has an option to remodel their floors, sometimes with wood, sometimes with thick pile carpet. And I go to the flashlight going to the door, and you can see how it's sealed or not. And if the common return is the hallway, as in this example, some units will exhibit fairly normal humidity, and others may be restricted based upon the confinement of the air movement under the door in return. But this happens in homes too. If you have a master bedroom suite, that through showering is going to increase the latent heat load into the air, and you put some real plush carpet up to the door, that air will be restricted in its ability to get back to the HVAC, assuming it's not ducted or have overflow ventilation. There are also some operational errors. One really real simple is just take a flashlight and look at the air return, the filter. And if they have dogs and cats, you're never disappointed. It's really, really plugged up. And sometimes I'll change it out. We're not supposed to manipulate too much, but if it's really bad, I'll tell maybe the public adjustments with me. They say, hey, look at this. But there are other elements too that contribute to operational errors. And one is people who put these beautiful new hurricane-proof windows in their home, then they cover them with shutters, wooden shutters. Now, from an aesthetic point of view, it looks great, but from a functional point of view, they're creating a very damp, dark circumstance in their home, despite their beautification efforts. And the efficiency, they've added more efficiency. But shutters, curtains, drapes, all those things reduce sensible heat load to a home. And if you reduce the sensible heat load, then you're decreasing the frequency that the HVAC is going to activate. That's going to reach the set point temperature. So it's not complicated. Of course, there are some simple things like you change the air return filter very frequently, or do you have common obstructions of the condensate line. But if you're going to remediate a home after water loss, assuming it didn't originate from the HVAC, photograph the HVAC closet to see if those the wood framing or the galvanized steel that supports the HVAC is corroded or deteriorated. And what I usually do is I take out my Leatherman knife and I'll poke it through the framing along the base and see how far it penetrates. If it goes for an inch or more, it's been wet before. It has leaked before. But it gives you some clue as to the management and maintenance of moisture in that home during or prior to the event. I talked about diminished sensible heat load, and there are other things too that occur usually after you've had a water loss, and that is that if the homeowner or the business owner has gotten a substantial reimbursement for the loss, they'll start improving things. And I've seen this not only in homes, but in municipal buildings, where they may not only change out the windows, they may change the color of the roof. something from gray to white, because it's more reflective. Or they may change the colors of paint on the walls facing south. And so as a result of those reflective surfaces, they're changing the sensible heat load to the building. And they haven't modified anything with the HVAC system. So it was meant for a certain amount of tonnage. For a home, it may be, say, 4 or 5 tons. For a commercial building, it may be 20. But those modifications greatly diminished the latent and sensible heat loads for the building, then therefore making it more likely to short circuit or to run in a diminished amount to properly remove sufficient humidity. Another one is replenished attic insulation. And you can always tell when the homeowner did it. It's like 3 feet deep, right? If 6 inches is good, 2 feet's even better. Or worse, during the course of the replenishment of the blown-in insulation, they've covered up the ductwork, right? And as a result, now, I mean, the ductwork is cool. It's transmitting cool, conditioned air to other parts of the room. If you cover it up, it will condense moisture. If you run your hand under the ductwork, you'll feel that it's wet. And it gives you an idea of why there's this streak across the ceiling. But that overabundance of insulation is not uncommon, especially if maybe a friendly neighbor has helped contribute to that replenishment. Landscaping. Trees grow around your house and people like to landscape. Those also contribute to diminishing sensible heat load over a period of time. So if the home was built, say, in 1990, and over the course of 10 years you've had landscaping that has now diminished the sensible heat load to windows and roofs and so forth, it'll diminish the amount of heat that it'll gain and may exceed the capacity of the HVAC to cycle frequently enough to keep it dry. Also, when kids go off to college, empty nesters, and my wife and I have been empty nesters. Our house isn't big enough to be that concerned about the 4 kids that left, but nonetheless, many times they'll just shut off a part of the house and say, well, we don't go up there anymore, that was our kids' room. It means this whole second floor is not being used, and I wonder why. There's a challenge with moisture management on the second floor and mold growth around the walls. So that's something to consider, again, as you document when you're assigned that project in a home, these variables that can affect moisture management later on. Closets with scuttles. Classically, in master bedroom closets, there's a scuttle, and there's a complaint that my shoes are moldy. And oftentimes, not always, but I always find these on the north side of the home. And the north side of the home is going to be cooler, naturally. And I found that in our house, that I had to put a supplemental dehumidifier in the master bedroom. Not that it wasn't improperly sized, it just was cooler and damper than the south side of the home. And it would fill up, especially during the winter months, between, say, about October to maybe February. Every day, 2 or 3 times, I offload the water from the dehumidifier, simply because it was a cooler portion of the home. So the point is that when you enter these homes and you see these features, especially closets that are vented, but they may have a solid door, like a solid mirror door. Well, that cool air is being captured by the master bedroom closet, and it will naturally elevate in humidity content and cause mold to grow on shoes, ties, anything that has more organic matter than it should normally. These are kind of fun mysteries. You go to a multi-family condominium, and there's a claim that the dishwasher leaks. And sure enough, on that tile floor is this puddle of water. So you operate the dishwasher, it doesn't leak. But the homeowner's an advocate, it leaked, it must be leaking, the floor is wet. Indeed, the floor is wet. But something tells you that moisture is condensing on that floor for a reason. So you go down the floor before, if you can get in, go to the occupant directly beneath, and what I have found is a misdirecting or redirecting of the air supply for the kitchen, not into the kitchen because of a modification of the lighting, to the floor above. So that spot on the floor in the unit above is being cooled, but it's not because it's cooler, it's being exposed to 55-degree air from the unit below, causing water to condense in the unit that the woman is in. The same thing can happen when you walk into a unit and the ceiling's dark. You know, why is the ceiling dark? There's been no leak reported. Many times it's because there's a differential temperature in the unit above that's causing condensation to happen on the ceiling, and sometimes it's very specific. It might be a very precise square that represents the room above. But nonetheless, the point is that when you have these abrupt thermal gradients between floors, there can be consequences in terms of condensation on surfaces, both the floor and the ceiling. It's not uncommon that once the restoration contractor has done a really good job, they've removed all the contents, they've been placed in, quote, air-conditioned storage, which is another story in itself. But they're retained, sometimes for 3 to 6 months. They're returned, and they're returned contaminated. And that's been not uncommon lawsuit as well. But the point is that, you know, you may have some affinity for Uncle Pete's, you know, old leather sofa because he was a great guy, but you may not want to bring it back after it's been exposed to a prolonged humid environment and it's just slightly green. Oh, it's okay, it's just slightly green. But you bring that back in, it's going to kind of contribute to the fungal population in that unit. Also, materials that go to Goodwill. Now, when we bring things to Goodwill, they're not necessarily in the best shape, especially furniture, but they get recycled. And if you have someone who is doing their shopping at, you know, Salvation Army and Goodwill, they may be introducing some components after the loss into their home that's related to furnishings. So if they don't match or they're somewhat irregular, you may inquire about that in a means to describe your defense as to why things have changed. And that's always a question I ask. You know, there's been some mold growth. I say, well, what's changed? Oh, nothing. Well, have you changed, like, for instance, the air conditioner? Oh, yeah, we went to 3 ton to 4 ton. And they don't think it's a big deal, but it's a big deal. It just doesn't work out that way. So you might want to confirm if you're getting contents returned back to the home after a loss, and what were the criteria for cleaning prior to the return? Usually, they're very limited. They've just been put away in storage and some surface cleaning, but it's pretty limited. So you might wonder, how long does it take for the mold to grow after it's been in damp, humid conditions? And so years ago, I worked with Chin Yang and Dr. Dabri Lee on looking at a variety of materials on how fast they grew mold, especially on fabric. And years ago in Philadelphia, I presented this paper to IICRC. I remember Mike Pinto right in front of me during the course of the presentation. And so he looked at, through the Detergent and Laundry Association, we had some control fabrics, silk, cotton, polyester, and wool, and we subjected them to stachybotrys, penicillium, and under humid conditions, and to see how long it took for the mold to grow, and if you could actually clean it when you were done. Well, the first question was answered about 30 days. If there's supplemental organic source on the fabric. Clean fabric does not grow mold because it cannot break down the fibers. It doesn't break down wool, it doesn't break down polyester or silk. You have to add something to it. That's why many of us have seen in homes that have gotten flooded, the guy's ties are all moldy, where he spilled things on the silk tie, right? You've seen that? Or the crotches are all moldy in his pants or the underarm. We've all seen it all. So the point is that you have to add a source of organic matter, sweat, food, hamburger, grease, whatever it may be. But that's what you need in the fabric. And it grows pretty quickly under, I call these worst case conditions. About 20 to 30 days, you're going to see mold grow. So if you see that happen, that's probably the circumstance. We also looked at plywood, and that's the shot in the middle. And at the bottom, it's actually in a 1/4 inch of water. So water is being absorbed by capillary action, but the top is not. It's just exposed to high humidity, about 95%. And mold grew there after about 31 to 40 days. So high humidity on plywood, but not liquid water, about 31 to 40 days. Then the far left, another paper I did with Chin Yang and some colleagues, we looked at gypsum wallboard assemblies. And they were constructed with pressure-treated lumber or non-pressure-treated lumber, but we were concerned right here with the gypsum and the paper covering. And you can see that this area, right around where it says 21-2, that's the 21st day, that paper over the gypsum has not been affected by capillary action. That's just humidity. But after 21 days, you can see mold growth. So again, under worst-case conditions, but you can see in all three scenarios, it takes about a month or a little bit more for the mold to show up. Now, why am I mentioning that? Because if you have a restoration project, and sometimes you get a little inkling from the client if you think there might be a problem, you might want to leave some criteria of what you expect for that home to be prepared and sustained with regard to the operation of the HVAC, about the return of contaminated products, about general capture and water losses and cleaning and drying and so forth. But lay those out in a nice way, and then you might want to do a phone call after about a month or two, just to inquire. Have you seen anything unusual about the house? Does it seem kind of damp in there? Or you might even leave like a couple of hobos. Say, you know, we're going to have a little quality control here. We're going to leave 4 hobos around your master bedroom, in your closet. We'll come back and get them in 30, 90 days, and we'll just check it out. But as a kind of an assurance that there hasn't been anything unusual that has elevated the humidity, that's based upon their performance, not yours. So that's it. Follow-up call. They understand that they have some responsibilities, and now you have some clues as to what to look for. Any questions? Right here.
When you're discussing about the microwaves and the dryers and such for negative pressure, when you're discussing the negative pressure created by dryers and microwaves and so forth, is that something when the house is engineered and constructed is taken into consideration by HVAC technicians and so forth?
No, because some of those variables are up to the homeowner. Yeah. And what if they buy a used piece of equipment, a new one? We just bought a new one because it started to fail. And I was surprised how the capacity of the dryer was so much larger than the old one. Although they're kind of the same size, it was much bigger. So the answer is no.
So even as a brand new home, there's too many variables to where...
Well, I think in the manual J, there may be a consideration for the volume of air discharge outside. But other than that, the builder doesn't care. Back here.
When you were showing the effect of the mold growth on the 21 days for the drywall, the 30 minutes for the plywood, you said high humidity.
Right.
What percentage were you referring to?
95%.
Okay, thank you.
Okay. So, and why do we do that? Because if we went to 90, 85, 80, that experiment would take forever to figure out, right? I just do worst case, and that's my argument. And say, well, I don't know what the humidity was, but under worst case conditions, it can grow as fast as 30 days or so. And that helps. But there's a lot of variables as we lower the humidity. And if we went down to 60, we'd probably wait a lifetime, perhaps, you know.
You said mold begins to grow and mold as you saw, colonize in 30 days.
Right.
Did you do any surface sampling earlier to see if it had already begun to colonize, but the colony wasn't big enough to be visually observable?
Okay, so in the wet portion, in 2 or 3 days. And by 7 days, on the part that capillary action, it was, you could scrape it off with a knife. In the area above that just had high humidity, it was not easily visible. I did not see it. But after probably, you know, let's say, be conservative, at least 27 days, you start to see a little speck at the top. But after 30, 35 days, you definitely saw it. But in the area that's wet, it's just a couple of days and you begin to see it. And we had another publication where we actually immersed a variety of wood materials. And within a couple of days, the top was just covered with mold from the nutrients extracted from the wood and then the growth from the fungal and bacterial particles in the air and the water. But that was all pretty quick. But in your case, it took longer because it was not, didn't have free water. Shall I say that, let's put it another way. The water activity was apparently too low for it to initiate as quick at the top as at the bottom.
Quick question here. Now, are you always using clean water, or have you ever tested like category 3 water to see if that grows faster?
Well, we always use tap water, because, I mean, for most leaks, I mean, it's tap water that leaks. If I use a category 3, it'd probably be faster, because it just got more inoculant in it, right? But the other thing is this, years ago, we were asked by, what's that company where you put things down your septic tank to? Pardon? Ridex, right. We were asked to do the research on whether or not it was effective. I was with another engineering firm. And the argument was, how do we define normal fecal data? And there was so much controversy. I mean, do we actually contribute ourselves to make this stuff? And are we normal enough to make this mass, to do the testing? And so we said no, but someone did it. But I know it says this. Yeah. Is that your question? Over here. Hey, Bob.
Do you have an opinion on biological growth under a ceramic or marble floor as a water effect?
Okay, so we did a study years ago in Canada, and there was a large flooding event, and we argued with our client, we'd really like to check out whether or not there's mold growth under the tiles in multiple homes. And we published this, I think it was with the American Society of Civil Engineering. And what we found is that in areas of the home that did not have sources of food, kitchens, even dining rooms, that there was not mold growth under those areas. But in areas where you pulled the tile around the grout lines where sugar, basically sugars, had penetrated through the grout, or in dining rooms where you learn that they put the high chair and the baby constantly spilling food, those clearly had fungal growth on the concrete beneath those areas. So whether or not mold is present under vinyl or ceramic tiles is dependent upon was a source of energy added. But if there's no energy added, mold doesn't grow on concrete. There's no energy source. But if you supplement it, it will. Any more? Bob, did that answer your question?
Yes,
Okay.
but I have another.
All right, again, it's an honor to be here. Thanks so much.
Thank you, Dr. Moon. Next up is Dr. Richard Shiney. He is the Program Indoor Air Research person at Tulsa University.
Hey, good afternoon. I'm honored to be here. I was here last year and I appreciated the invite. We're working on many different projects right now. I'd love to cover them all, but we can't do it all. But we'll go through a lot about ATP. How many of you use ATP? So a good fraction of you. And it's becoming more and more useful in the field. So because of that, it's very simple to use, but at the same time, it's very simple to screw up too. You could do it wrong in a heartbeat. Yeah, I gotta tell you, where's Ralph? Normal, fecal, Ecology? I don't know, I've been looking at normal fungal ecology, but that's one for you all to figure out. So anyway, part of what I'm going to talk about and introduce is what I went over last year to some extent, and then we're going to go on from there. Okay, so I love talking about schools and everything because schools definitely are a great study area if you're doing research, work of that sort. When, many years ago, when I stepped into it, I'm a chemical engineer. I'm not a microbiologist. And so, when I get in a group of microbiologists, I felt like this, kind of like trying to learn the environment underwater and swimming and drowning often. But after many years, and I've had a lot of education, but in the field it's much different. I learned, I began to adapt, I got used to it, and I'm here today, and that guy, fish, transformed out of water. And that's what I am for you. And that's what you've got talking to you today. That transformed guy, talking about all of these issues that carry over that we have to deal with. Like I said, schools are definitely a pit stop. I mean, they are a petri dish. There's no doubt about it. And I talked about that last year. And there are so many ways you could go wrong. And in a study that we did, one of the studies that we did with Yale University, that we published on not too long, well, we published a few papers, so I'll refer to some of them. But this has to do with what you find on desktops. And it has to do with bacteria and fungi, and the interesting thing is that if you look on a typical surface, you're going to get a lot of environmental types of like soils and other types of fungi or bacteria. But when you're talking about desktops, the predominant amount of what you're looking at is all human-born. And even in households, you don't see it to the extent that you see it on school desks and things of that nature. So, which is important to understand that desktops do represent that surface, that a vehicle for exposure to other people's microbes. Right? And so we should be aware of that. High-touch objects in general, kind of. And again, it shouldn't surprise you. I can't help from bringing this up. A gentleman came to me right during lunch and said, high-touch objects. He's in the casino. I would not want to touch those. Some of those knobs that are in there, and they're going after it. And he told me he was watching one of them, and he kind of drool on his hand, and he'd go right back at it. Keep it sticky, I guess. I don't know. A study we'll talk to you about 2 or 3 years from now. I'd like to get into it. Now, if you look at those surfaces and you're dealing with ATP does not directly measure viruses. So we were looking at desktops and we were looking at viruses on surfaces. And first of all, the contamination can be imprinted on an inanimate, tabletop, foamite surface, and it can be easily spread by contact transmission. Resuspension is also very important, related to carpets and everything. And by the way, I have so many things I'd love to talk to you about. California, the CHIPS program, how many of you are aware of the CHIPS program in California? California High Performance Schools, they put out standards related to everything, indoor air. It's kind of like LEEDs, but it's California style. And they've got a new one out on carpets, and you all should pay attention to that. You really should, because it applies, carpet cleaning and things like that. And all carpet, it has to do with flooring, but carpet's important. So you might tap into that, be something, because it's out for comment right now, and it needs work. I told them this morning it needs work. So, but resuspension related to flooring is also very important. And the persistence of viral load on surfaces can last hours to days. So that's important. And so we were looking at desktops in schools, and we were looking at different viruses. Adenovirus, coronavirus, and others as well. Most of them respiratory viruses as well. And we published on this. And not too long ago, I think a few years ago. And with that, what we found were that in typical schools, you have a scenario where in the 1st through 5th grade, it depends on how many people have touched the surface. And in 1st through 5th grade, one kid comes in, one kid stays on the desk, and that's it for the day, right? So, and with that, the probability of a virus being on that desk, adenovirus, about 7%, rhinovirus, typical colds and what, 9%, coronavirus could be 3%. Any respiratory virus could be up to 19, 20%. But the thing is, it's not one person at a desktop when you get into 9th grade, 7th grade, and above. You've got multiple people sharing desks. And this is important. It doesn't have to be school. If you're looking at a desktop, or you're looking at a tabletop, you're looking at, an office facility, how many people have touched that surface? And now, if we look at those percentages, they go up upwards to 30%, rhinovirus, almost 40%, coronavirus, 15% probability that it's on that surface. And any respiratory virus can go upwards to 65%. So it's important to understand that the number of people frequenting that surface, that desktop, is very important. I'll talk later, but the microbial load related to what you typically find with ATP, what we're going to step into, which does not measure viruses. It does still correspond because of the fact that viruses are present when you're looking at microbial matter such as bacteria and other things as well. And we'll talk about that. The benchmark's important. You got to have some benchmark. You've got to have that metric. And I talked about that last year. So we need to validate. And how can we validate? Well, there are a number of ways. You could use visual. Not really. I mean, that's pretty much worthless. You're not going to get anywhere with visual. You could use fluorescent markers. I mean, how many of you have used fluorescent markers before? I mean, they're not that great as a whole, but they're a tool. They're something you can have in your toolboxes. And then you can look at ATP. Fluorescent markers, what you do, you spray it on, okay, and then you come back later and has that marker, you're looking at it through UV light, and has the marker now dissipated? Is it gone? Is it removed? Have they attempted to clean it? And that's okay, because it shows you can indicate whether or not there's been an attempt at cleaning. It doesn't mean that it's clean, but it can tell you that somebody's come by and they've tried to clean it. But the problem is that the overall biocontamination on the surface may not actually be lowered. And because of the fact that you often have with cleaning, we only have kind of that going on, and that is not cleaning. Cleaning is going to have to move across the surface one time, and you can't just rub like that because you are smearing. So there are differences, and that's why fluorescent markers only give you an indication of an attempt to clean, but not the fact that it is clean. So we move to ATP, and which is becoming more and more used in the draft document related to infection control and cleaning of infectious areas or such to control that, that IICRC currently has out. They definitely have a portion of that devoted to ATP as a validation method. So it is being used more and more, certainly by your industry, and that makes sense. So, a quick review. ATP, what is it? Well, it's present in cells, whether they're whether they're alive or dead. It's a useful indicator. It's very inexpensive. It's quick to be able to use. It will give you a marker of cleaning effectiveness related to the bioburden, how much residual biocontamination may be on the surface after cleaning. And we published on some of that. I told Holly I would give her the notes on this, and we'll be sure to have them available, please. But anyway, one of the first papers we published about 12 years ago with Gene Cole and others, we looked at ATP as a marker for contamination in schools. And what we were trying to do is find out what is the typical contamination on a surface area. And I showed this to you last year briefly. We had looked at 5 different regions. We did 10,000 measurements. And with that, what did we used 3 different luminometers. And there are problems with that because every one has a different readout, has a different range, has a different scale. So you pretty much have to select one luminometer and you got to stick with it, unless you know the relationship between them. And we've looked at that. We've done that. Working with Greg Whiteley in Australia and trying to get the correlation between the monitors as such. But there's variability within the monitors themselves. So it's still a challenge. We looked at classroom desks, we looked at cafeteria tables, we looked at bathroom areas. And again, I showed this to you briefly last year. I only bring it up as a reference